Okay, this chapter deals with linear programming, but before we can really get into that, we're going to talk about graphing linear inequalities, and then we'll get into systems of linear inequalities. This section shouldn't take long, but go ahead and read the notes here, and then let me just go ahead and show you how we're going to graph a system of or graph a linear inequality. So I've got two examples here. The first one says graph the inequality 2x minus 3y is less than or equal to 6. So the first example, just focus on this first row here, 2x minus 3y is less than or equal to 6. The boundary here is 2x minus 3y equals 6. And so all I have to do, I want to graph the boundary first. So to graph that boundary, I need to find the intercepts of this equation. So this is just a line, remember. So if I let x be 0 and solve for y, I'll get that the x-intercept, or the y-intercept is 0, negative 2. And if I let y equal 0 and solve for x, I get that the x-intercept is 3, 0. So I just get some graph paper, and then I plot the point 0, negative 2, and I plot the point 3, 0, and I get a ruler and I just draw a line through them. Now notice that this line is solid. It's a solid line because my inequality, since it has the equal to there with the inequality, that means all of the points on the line are actually part of the solution. So I have to draw a solid line to emphasize that. Now, I had to determine whether to shade below the line or to shade above the line. Okay, and so what I did is I picked a test point. And most of the time I'm going to use the test point right here at the origin, 0, 0. And all you do is you take that test point and you plug it into your inequality. So let's see, if I plug 0, 0 into this, I get 2 times 0 minus 3 times 0 is less than or equal to 6. Well, that says 0 is less than or equal to 6. Now, if that is a true statement, then you're going to shade the same side as 0, 0, which would be above the line. If that's a false statement, you shade the other side, which is below the line. Well, I got a true statement, so I have to shade the region above the line because that's where 0, 0 is. So notice here, if you look at this, it's already shaded, but you just get a pencil or marker and shade this side. And that would be the side that you shade. So all the points that are on the line or above the line are part of the solution. Okay, now let's look at B. B says 2x minus 3y is greater than 6. So notice it's the same equation, so I use the same equation. So obviously my boundary is going to go through the same points, 0, negative 2, and 3, 0. But when I drew the line, notice that I drew a dashed or broken line. That's because this inequality does not have the equal to with it. So that means that the boundary or the line is not included. So this is how I show that it's not included, just with a broken line. Now, I need to decide whether I shade below the line down here or above the line up here. So what I have to do is I'm going to test this point 0, 0, which is above the line. And let's plug 0, 0 in this time, and I get 0 minus 0 is greater than 6. Well, 0 is not greater than 6, so that's a false statement. And since I got a false statement, I have to shade the opposite side as my test point. So that means I shade everything down here. And you can see, again, it's already shaded, but you shade that region. Okay? Now, here's a couple more examples. This is 2x plus 3y is greater than 12, and 2x plus 3y is less than or equal to 12. Okay, so basically do the same thing. you draw the boundary, 2x plus 3y equals 12. Let x be 0, solve for y to get your y-intercept 0, 4, which is right here. And then let x be 0, let y be 0, solve for x to get your x-intercept, which is right here. Right there. There it is. Alright, then draw your straight edge through there, but make sure you draw a broken line because this one does not have the equal to with it. So we draw a broken line, and then we test the point 0, 0. And when I plug 0, 0 in here, I get 0 is greater than 12, which is false. So that means I have to shade 0, 0 is below. And since I got a false statement, I have to shade the opposite side. So I shade above the line. So that's, I'm not going to shade it. You can see the shaded region. Okay, and then on the other one, 2x plus 3y is less than or equal to 12. Same boundary. Okay, same boundary. But again, notice here I have a solid boundary. Okay, and that solid boundary because of the equal to that's with this inequality. And then here's 0, 0 right here, and it's below the line. And if I test 0, 0 for this inequality, I get the statement that 0 is less than or equal to 12, which is true. So I shade the same region that 0, 0 is, the same side of the line that 0, 0 is on. So I shade this line. Now all of these regions are actually considered to be unbounded regions because they go on forever and ever and ever. Like for instance, this region over here, it goes, you know, on forever and ever and ever in that direction, and then this region goes on forever and ever and ever in that direction. So those are unbounded regions. If you wanted to graph, if you had inequalities like x is greater than 3, well, the boundary for that would be x equal 3, which of course is just a vertical line. But since it doesn't have an equal to, notice I drew a dotted or dashed line. And then all I have to do is identify which side where x is greater than 3. Well, obviously, greater than 3 would be to the right of 3, so I would shade that side of the line. And then for y is less than or equal to negative 1, well, if you graph y equal negative 1, that would be this line here, which is just below the x-axis. There's y equal negative 1, and since it has the equal to with it, I drew a solid boundary. And then you just say, just common sense tells you, well, what are the points that are less than negative 1? Well, it would be all the points that are below that line. So it would be shading that region. A couple of other things you might want to know is if you wanted to graph the region x is greater than or equal to 0, that would mean you're shading everything to the right of the y-axis. Now if you were doing x is less than or equal to 0, you'd be shading to the left. If you wanted to do y is less than 0, you would shade everything below the x-axis because that's where y is less than 0. And this should be a dashed line. I don't know if you can see it. That would be a dashed line because I didn't say less than or equal to. I just said less than. And then if you were to put these two together, where x is greater than or equal to 0 and where y is greater than or equal to 0, that actually is what we call a system of inequalities. And when you put those two together, you actually are going to get just everything that's in the first quadrant. So basically, you're going to get everything on these two segments I just drew, plus everything out here in this region. Now, this is important. We'll find out this is important later, because what we'll find out is we'll be talking about things that we might be manufacturing, and common sense tells you that when you manufacture things, you can't manufacture a negative number of them, so therefore x or y will have to be greater than or equal to 0. Okay, so that's basically that. Let's see, there's some other examples down here, but I think that's pretty much it. That was just another example, but that's pretty much it on that section. So this was really just the introductory section. Your instructor may not even cover this because sometimes they go just straight into systems of inequalities, where here I'm showing you just mostly how to graph just a single inequality.